SIS routers can only belong to one area. Is this true or is it false? Most people get this wrong. And if you're coming from OSPF, I'll show you exactly why. All right, here's our topology. We have 7 routers across 3 ISIS areas. R1 sits alone in area 49.0001. R2, R4, and R5 are in area 49.0002, and R3, R6, and R7 are in area 49.0003. Now, we are going to configure 3 different ISIS router types today. R1 will be level 2 only. That is our backbone router. R2 and R3 will be our level 1, level 2, and those are our border routers, and they're the key to answering this question. R4 through R7 will be level 1 only. Those are our stub routers that only care about their local area. All 7 routers already have their IP addresses configured. We're going to configure ISIS from scratch so you can see exactly how this works. So let's start with R1. So as we can see here on R1, we currently have our interfaces assigned and configured. So we can see serial 10 and serial 11 are configured with IP addressing. So what we will do now is get into global configuration, and we will enter router ISIS. And now we will assign a network. So we will assign net, and then from here, this is where we specify 49.0001, the area, .0000, .0000.0001, which is the host, .00, which is the NSEP, which we'll discuss in a second. So let me break this down real quick. So the first part, 49.0001, is the area ID. That tells ISIS which area this router belongs to. The middle section, 0000.0000.0001, is the system ID. That's unique to each router. And the 00 at the end is the NSAP selector, which is always going to be 00. All right, so we will go ahead and configure that. Now we will assign it a type or a level. So we will assign IS type, and this is going to be level 2 only. Okay. R1 is our backbone router, and ISIS level 2 is the backbone. It's a similar concept to the OSPF area 0, but it's not an area, it's a level. That distinction is going to matter a lot in a few minutes. All right, so now what we will do is we will log adjacency changes, and we have a hype in here, okay? And then for any of our adjacency changes that we do want logged, we will do all. Okay. Now we will exit. We need to enable ISIS on each interface. Junos is the same way. We will talk about that possibly in a future video, but for now, we're going to stick to Cisco. Unlike EIGRP, ISIS doesn't auto-discover networks. You have to enable it per interface. All right. So what we'll do to start is we will do int serial, and I believe our first is going to be 110. Yep. So we'll do S10. Okay. And then we will do IP router ISIS. Okay. And then we'll do the same thing with serial 1 and serial 2. We'll do interface serial 11, and we'll do the exact same command, IP router ISIS, and then we'll do this to 12, same thing, router ISIS. And on 1.2, it does not appear as though we have any interfaces here. And that's because this is router 1 and we're on the wrong one. But that is okay. We are good to go here, and now I understand why I got that error. So we're learning on the fly. So let's go ahead and save our changes here for R1. Now we're going to go ahead and move over to R2 real quick. Okay, we'll enable. We'll get into global config. Now we can see that we do have all of our serial interfaces here. Okay, so let's do this. For R2, we are going to do the exact same thing. So from here, I just want to come up real quick. All right. So now we're good with R1. So let's do R2 and R3. And this is where it's going to get interesting. So the first thing that we're going to do is we're going to get into router ISIS. Okay. And then we'll give it its network. And for brevity, I'm going to go ahead and I'm going to actually copy this because it's a very long statement here. Okay. And then we're going to do IS type. And then from here, we're talking about router 2. So we're going to have level 1 and 2. So level 1, 2. Okay. We'll go ahead and do that. Level 1, level 2. R2 now runs both levels simultaneously. Think of it this way. R2 has 2 jobs. Job 1, know everything about area 2 at level 1. Job 2, know how to reach every other area at level 2. 1 router, 1 area, 2 routing databases. Now, here's the difference from OSPF. In OSPF, ABR literally has 1 interface in area 0 and another interface in area 1. It belongs to both areas at the same time. ISIS does not work that way. R2 belongs to area 49.0002, period. It participates in 2 levels, not in 2 areas. Remember that. Okay, so now from here, we will go ahead and we will log our adjacency changes, all, no change there. All right, so we will do IP router SIS, come back, going to serial 1, same thing, serial 2, same thing. And I think we should be good to go. Okay, so we'll write our changes. We'll pop over to router 3. Okay, and then here we'll get in the global config. We already have IP addresses on all these routers. So we're gonna do the same concept. It's just with a different area. So it'll be area 49.0003, okay? So let's first get into router ISIS. And then again, I'm gonna go ahead and copy this for brevity, okay? And now from here, I'll do an IS type level, and this is going to be 1 and 2. All right. And then we'll go ahead and we'll log adjacency changes all. Good there. So SE10. Okay. Got it. And we'll do IP router ISIS. Go up, get serial 1. ISIS, and you can see as we do this, we're getting adjacencies formed. Okay, so that's a good thing. All right, so we should be good there. I'll go ahead and do config. So R3 is in layer 1, layer 2 in area 49.0003. Same 2 jobs as router 2, just in a different area. So now we got to focus on the stub routers, R4 through R7. But before we do this, let's go ahead and see what we see so far. So show ISIS neighbors. Okay. All right. As we can see here, we do have a neighborship and an adjacency with router 1. Okay. So it's directly connected interface. So that's exactly what we want. So we're looking good so far. Well, let's move on in the interest of time. So now we're on router 4. So we're going to go ahead, same thing here, except different role. So get the global config, and then we'll go ahead router ISIS, okay, and then I'll give it its network, and then from here this is going to be a level 1 only. All right, so IS type level 1, actually that's it, level 1. Yep. R4 is in area 49.0002, same as router 2, but router 4 is level 1 only. It only cares about its own area. It trusts router 2, the L1, L2 router, to get it everywhere else. You'll see that show up as a default route in the route table or routing table later. Okay, so let's see. We'll go ahead and we'll log adjacency changes all. Nothing crazy here. We're basically doing the exact same thing as the other routers, but they're serving different purposes. Okay, so let's go ahead 010. Okay, and then we'll do an IP router ISIS. Okay, and then the last we want is, we also want to do our loopbacks, because again, these are our stubs. So we'll go ahead and loop, and we'll do 0. Okay, and then we'll do the same command. We'll throw it in the ISIS area, so we should be good there, and we'll write our changes. Okay, we're enabling ISIS on a loopback because we'll use these loopbacks to verify cross area reachability later. So now let's move on to router 5, and same concept here. So we'll get into router ISIS. Okay, and now for our network, this is also going to be in network 2, if you will, for brevity, but it's identified as a level 1 only. Okay, so level 1. We'll go ahead and log adjacency changes just as the others, and now we'll get into 010, and then we will do a IP router ISIS, and then the same thing here. We're going to get into int loopback 0, and same thing, we'll put in the ISIS area, and we will write our configs. Router 6. So router 5 is a layer 1 in area 2, just like router 4. Now R6 and R7, same pattern, but they're going to be in area 49.0003. Okay, so on to router 6, and we'll go into global config. All right, here again, we will get into router ISIS, and we will put our network as we depicted before, and then we will do an IS type. And remember, this is a stub, so level 1, and then we will go ahead and log adjacency changes as before, and then we will get into interface 010. Okay, and then we will put it in our router 0, or I'm sorry, our interface, or router ISIS. Wow, routers and interfaces and routing protocols. Good times. All right, so let's get our loop back in there as well. And we were done with router 7. Moving on to router 7, and router 7 is our last one. I'm doing this for muscle memory mainly, and I'm hoping that you'll be able to follow along at home to also do this as well, because not that I want you to memorize commands, I just want you to see the repetition for how the technology is implemented on this certain operating system, which is Cisco. Okay, so again, router ISIS. So we get into the actual routing protocol, and now we're going to give it an area. All right, looking good so far. And then we'll give it a type, which in our case is going to be level 1 only for router 7. And then we'll go ahead and we'll log adjacency changes, and then we'll assign our interfaces into the protocol. Okay, so 10, and we will go ahead IP router ISIS, and then for this one we also want loopback 0, and same thing, we'll write our changes. Okay, all 7 routers are configured. Now let's see what ISIS built for us. So let's go over to router 2. Okay, and we'll go ahead and end this here. So let's do a show ISIS neighbors. All right, we have 3. So if we look at router 2's neighbors, it has an L2 adjacency with R1 and L1 adjacencies with R4 and R5. Same router, same area, but different adjacency types per interface. That's already telling us something important. Okay, so now we're going to roll to R1. Enabled show ISIS neighbors. Okay, so for R1, it only sees layer 2 adjacencies. Router 2 and router 3 are the only ones that show up in R1's neighbor states because it's a backbone only. Okay. How about R4? Okay. One of our stubs, right? So on R4, we'll go ahead and we'll do a show ISIS neighbors. R4 only sees one L1 adjacency with R2. That's all it needs. It trusts R2 to handle everything else. Okay. But the real proof is in the database. Okay. And to see that, let's go to one of our border routers here. Okay. So what we'll do is a show ISIS database. Okay. So here's the proof. R2 has a level 1 database with LSPs from R4 and R5. Those are its area 49.0002 neighbors, and it has level 2 database with LSPs from R1 and R3. Two completely separate databases on one router, two databases, one area. Now let's go over to R4. So from here, we'll go ahead and look at our database. All right. R4 is going to be L1 only. All right. It has one database, one level, one area. It only sees what's in its area, which is 49.0002. Okay. Now, how about R1? R1 only has a level 2 database. R1 only participates in the backbone. It doesn't know or care about what's happening inside Area 2 or Area 3 at level 1. And what about reachability across all areas? So from here, we'll run to one of our routers that has a loopback address. For router 4, we'll do a show IP route, and we'll do an ISIS. Okay, so R4 is layer 1 only and in area 49.0002, but look at this. It can reach 6.6.6.6. That's R6's loopback, and R6 is in the area that is 49.0003. So how is R4 reaching a router in a completely different area? R2 is doing the work. All right. So L1, L2 routers automatically propagate L1 routes up into the level 2 backbone, and they inject a default route back down into level 1. So stub routers like router 4 know where to send inter-area traffic. You can see that default route right there in R4's routing table, which is pointing at router 2. And as we can see there, we have the router 2 being pointed at. So let's prove it end to end. So ping 6.6.6.6. Okay. We can see right there, R4 is in area 49.0002, reaching R6 in area 49.0003, all through the L1, L2 routers doing their job. So let's answer the question. The question we posed earlier. ISIS routers can only belong to one area. The answer is true, okay? But the question is designed to trip up people who confuse areas with levels. L1, L2 routers don't span areas. They span levels within their area. That's the fundamental difference between OSPF. An OSPF ABR, or area border router, has interfaces in multiple areas, okay? It literally belongs to area 0 and area 1 at the same time. An ISIS L1, L2 router belongs to one area and participates in two levels. Same job, completely different mechanism. Think of it this way. Areas define where you belong. Levels define what you know. So quick recap, ISIS routers belong to exactly one area, one only. L1, L2 routers participate in two levels, not two areas. Don't confuse areas with levels. Drop your answer in the comments. Did you get it right before the reveal? If lab verified routing content is your thing, subscribe, and more routing deep dives will keep them coming. Thank you for your time.